We hear it all the time, right? AI learns. But what does that actually mean? Today, we're going to break down exactly how a machine goes from messing up to getting it right. And we'll do it with a simple story I promise you won't forget.
So let's start with a big question. How can a machine, it's just a bunch of code, right? How can it genuinely learn to get better? It's a great question. And the answer, believe it or not, doesn't start with complicated math. In fact, you can understand the entire concept through a little story about a group of students, a teacher, and a classroom project that goes a little bit wrong. Okay, so picture this. A teacher assigns a group project. The goal? The entire class has to work together to figure out what kind of tree is in a photograph. Sounds easy enough, but the way they're set up is really specific. Here's how it works. The students in the very back row start by sharing their initial guesses. Then they pass those ideas to the students in the row in front of them. Those students refine the ideas and pass them forward. And this keeps happening all the way to the front of the class. This whole process is what we call a forward pass. Finally, all that information gets to Jabari, the student sitting right at the front. He takes in everything he's heard from the rows behind him and proudly announces the class's final answer. But, yeah, there's a problem. The results come in and, oof, it is not good. Out of 7 different tree photos, the class only got 1 right. It was pretty much a total failure. So, what do you do now? How do you fix this? This is where the teacher steps in. And instead of just shouting out the right answers, the teacher uses this really clever strategy to help the students figure out how to work together better. Now, what's really cool about this is how the teacher gives feedback. They start with Jabari at the front, the person with the final wrong answer, and then works their way backward through the classroom, row by row. And the feedback is super specific. The teacher might say something like, "Hey, Gasper, your guess was a little too loud, so your opinion is kind of drowning out the others." Or maybe, "Hayu, you relied way too much on what Daniel said and didn't listen enough to Fatima's idea. We need to balance that out." So here's the absolute key. With the teacher's help, every student learns to adjust the strength, or you could say the weight, of their own contribution. They're not just guessing anymore. They're learning how much to trust themselves and how much to trust their classmates. After just 1 round of this feedback, they try the whole thing again with 7 brand new photos. And look at that. They got 3 right. That's a huge improvement. They're still not perfect, but you can see the learning process has actually started. Okay, that's a fun story. But now for the main event. Let's finally connect this little classroom directly to the world of artificial intelligence. So, what on earth does this classroom full of kids trying to identify trees have to do with how a really complex AI model learns? Well, it turns out it has everything to do with it. This is where it all clicks together. The students in our story, they're just like the nodes in an AI's neural network. And the teacher's whole process of working backward to give feedback, that's a famous algorithm called backpropagation. And the volume of each student's voice, their influence, in AI, we call those weights. So backpropagation is the real engine of learning here. Just like the teacher, it looks at the final wrong answer and works its way backward through the entire network to figure out which nodes were most responsible for the mistake and exactly how they need to change. And what does it change? It changes those weights. A weight is really just a number that tells the network how much to care about the information from any single node. A higher weight is like a louder voice. Backpropagation is all about adjusting these little volume knobs up or down to get a better answer next time. And the thing that kicks this whole process off is something called loss. That's just a fancy term for how wrong the model's prediction was. When the class only got 1 out of 7 right, the loss was huge, so the teacher made some pretty big adjustments. As the model gets better and the answers get closer, the loss goes down, and the adjustments become smaller and smaller, just fine-tuning things. Understanding this simple classroom analogy is so powerful because it really gets you to the absolute heart of how most of the AI systems we use today actually learn and improve. So what's the big takeaway here? It's that AI learns by working backward from its mistakes. That process, backpropagation, is all about assigning blame and then adjusting the volume, the weights, of different parts of its brain. It's this constant cycle of trying, failing, and then tweaking things to get better. This isn't just one little trick. It's the foundational technique that powers so much of the AI in our daily lives. Now, if this whole process of how AI actually learns fascinates you, and you want to understand how it's being used to build real-world products and transform entire industries, then I've got the perfect next step for you. I really recommend you join the AI Product Management Playbook by Deepak Dio over on LinkedIn. You'll get incredible expert strategies on agentic AI and product leadership that will help you stay way ahead of the curve. The link is right there in the description. So next time you see an AI do something amazing, you can just remember that simple classroom, patiently learning from every single mistake.